Okay, folks, welcome back. Today we are going to continue on with section 8.3, and we're dealing with SohCahToa. All right, so remember, SohCahToa, some old horse caught another horse taking oats away, stands for sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So in this example, I want to find the sine, cosine, and tangent of angle C. Okay, sine, cosine, and tangent of angle C. So first thing, I want to look at angle C. Right there it is. So sine is opposite over hypotenuse. So the opposite side, we go opposite that angle, it's 27. And the hypotenuse is 45. So we can now take a look at that fraction and say, well, hey, that fraction can actually be reduced. We know that 9 goes into 27 3 times, and 9 goes into 45 5 times. So therefore, the sine of angle C is 3/5. We do the same thing for cosine, but cosine is adjacent over hypotenuse. Well, the hypotenuse is always the side that the right angle is pointing to. So 45 is always the hypotenuse. So relative to our angle C, this side is adjacent to it. So then adjacent over hypotenuse. All right, well again, 9 goes into both of those. 9 goes into 36 4 times. And 9 goes into 45 5 times. And so the cosine of angle C is 4/5. All right, lastly is the tangent. And tangent is opposite over adjacent. And so again, looking at angle C, the opposite side is 27. The adjacent side is 36. And again, 9 goes into both of those. 9 goes into 27 3 times. 9 goes into 36 4 times. And so the tangent of angle C is 3/4. Okay, so that's a review from what we did yesterday. What we need to do today is go through and expand on this. So what we're going to do now is we're going to solve for a missing side in our triangle. And this is really why we learn trigonometry, why we learn SohCahToa, is that this is not a special right triangle. It's not a 30-60-90 or 45-45-90. And we don't have enough information to use the Pythagorean theorem like we did all right before break, but we have enough information to use trigonometry. So first thing we're going to do is write down SohCahToa. Do that first all the time. And what I want to do is find out what information I have. So we don't use the 90-degree angle. Okay, we have to have a right triangle, but we don't use the 90-degree angle. I want to use this 35-degree angle. So it looks like I know the hypotenuse, and I'm looking for the side that is opposite my 90-degree angle. So looking at SohCahToa, opposite is either going to be sine or tangent, not cosine, and hypotenuse is just in the sine, not the tangent. So I'm going to be using sine. Sine is opposite over hypotenuse. Well, unlike our previous problems, I know the angle. Rather than saying the sine of angle A like we've done before, I can now say sine of 35 degrees. And that sine of 35 degrees is going to equal the fraction x over 11, opposite over hypotenuse. And so like I said yesterday, our ratio is equal to a fraction. Okay, a trig ratio is simply a fraction. So the sine of 35 degrees equals x over 11. What we want to do now is we want to solve this as if it's a proportion. So put sine 35 over 1. And now I can cross multiply. So 1 times x is just x. And the sine of 35 degrees times 11 is going to be 11 sine 35 degrees. Now, one thing I want you to be aware of, the sine of 35 degrees is a number in and of itself, and it is not equal to 35. So I do not want to take 11 times 35. Sine of 35 is its own number. So if we take a calculator and we go into our mode, first off, we want to make sure that your mode is correct. So click on mode and make sure that it's not on radians. You want to make sure it's in degrees. Okay, once you have it set into degrees, you want to push quit. So that's the second key, and then the mode key again, which is quit. Now you're back and ready to rock. And so if I type in the sine of 35, this number is actually 0.57357643, blah, 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 blah. Keeps on going forever. So it's not 35. I can't use it like 35. It's together. It's always together. So what we want to do is, rather than messing with that big decimal, don't mess with that big decimal. Okay? I want to just type that into my calculator. So I'm literally going to say 11 times sine 35 in my calculator. So 11 times sine 35, when I put that in my calculator, it tells me that x, oops, let's do the proper color here. X is approximately 6.3. I want to round that to the nearest tenth. And so x is approximately 6.3. And there's my answer. Let's try one more of those. All right, here's another example. And again, I want to write down SohCahToa. Looking at my information, here's my angle. There's my angle. And so I'm given the opposite side, and I know the adjacent side. I do not know the hypotenuse. This is the hypotenuse up there. I don't know the hypotenuse, but I do know the opposite and adjacent. So that means I am using the tangent, because both sine and cosine use the hypotenuse. So I'm using the tangent. So remember, tangent equals opposite over adjacent. So we're going to take tangent of our angle, tangent of 16 degrees. Oops, that's one thing I should be writing over here. Remember, these never show up on their own. So tangent theta is opposite over adjacent. So the tangent of 16 degrees is going to equal the opposite side over the adjacent side. And so now what I want to do is I want to set this up as a proportion, and I want to cross multiply. 1 times x equals 13 times the tangent of 16 degrees. And again, once your calculator is already set up for degrees, all you got to do is set that in your calculator. Just take 13 times tangent 16. Make sure you're actually using the tangent key on your calculator. So x is approximately 3.7. All right. So I apologize that I'm not there to help you guys out on this right now, but please look around with your neighbors. Make sure that you're able to get 6.3 on this example when you're typing in 11 times the sine of 35, and make sure you're able to get 3.7 on this example when you are typing in 13 times the tangent of 16 degrees, to make sure everybody in the room can actually use their calculators properly to get the proper answers. Hopefully this wasn't too confusing. I'll see you all tomorrow.